A very good morning to everyone. This is Kapil Kumar, Assistant Professor from the Department of Computer Science and Engineering with AI from IIMT College of Engineering, Greater Noida. Today, I am going to discuss about software development lifecycle models. So let's start with basic introduction to the SDLC. SDLC stands for Software Development Lifecycle Model, and it is a framework or discipline that defines tasks performed at each step in development process. It is a process that gives a complete idea about developing the software, designing, implementation, testing, and maintaining a software. It ensures that all the functionality along with user requirements, objectives, and goals are addressed. In the earlier time, there was a term software crisis. A software crisis is a term used in computer science for difficulty of writing useful and efficient computer programs in the required time. The software crisis was due to using the same workforce, same methods, same tools, even though rapidly increasing in software demand, the complexity of software and software challenges. With the increase in the complexity of software, many software problems arises because existing methods were inefficient. If we will use the same workforce, same methods, and same tools after the fast increase in the software demand, software complexity, and software challenges, then there arise some problems like software budget problems, software efficiency problem, and software quality problem. So this condition is called as software crisis. This was the problem, and the solution for this problem is software engineering and SDLC. There are few objectives of SDLC: to minimize project risk through forward planning, to provide high quality software, to maximize the productivity, to provide a strong management control, and identify and assign the role and responsibilities of all involved parties. These are the phases that involved in SDLC. The first one is planning, second one is analysis, then design, implementation, testing and integration, and the last one is maintenance. So now we will discuss each and every phase one by one. The first stage is planning and requirement analysis. Requirement analysis is the most important and necessary stage in the SDLC because without a requirement analysis, without a requirement, we cannot uh, go further, we cannot proceed. If we do not have requirements, then on which data we can work. The senior members of the team perform it with inputs from all the stakeholders. Now, the stakeholders in this process may be the clients, the managers, the different clients, and maybe the members from the SQA team or managers. Planning for the quality assurance requirements and identification of a risk associated with the project is also done in this stage only. Business analyst and project organizer set up a meeting with the client to gather all the data. In this meeting, each and every requirement is gathered so that we can work further. This is the stage two, defining requirements. The document, we can document each and every requirement that we have gathered in last stage or in first stage. After collecting all the requirements from different clients, we can write up in the on a paper, we can say. After completing this document, we can use it as a we can say a contact between the software manager and the clients. This is accomplished through SRS, Software Requirement Specification Document. In this stage, in the second stage, we make SRS. This is a legal document, and the standard that is followed in this document is IEEE standards. The two steps or 2 points are common for every project. The rest of the steps can vary. It contains all the product requirements to be constructed and developed. And we have to get it accepted from the all project stakeholders, the parties that are involved in this stage. Now, this is the stage three, that is designing the software. After collecting the data, after planning the data, collecting the data, or document the data, we have to design the software. And we can design on the basis of the requirement only. The design that upcoming, we have to design the upcoming product, and the design can be architecture, user interface, and the features. The people who involved in this stage are architects and senior developers. These architects are not the people that design the building. These people can design only softwares. And the output of this stage is DDS, that is Design Document Specification, that explain how to code the product. Now, this is the stage four, that is developing the project. In this phase of SDLC, the actual development begins. Because in this stage, we are dealing with the codings. The implementation of design begins concerning writing codes. All the developers that are involved in this phase, they have to follow the coding guidelines. The programming tools we use, like compiler, interpreter, debuggers, etc., that are used in development and implementation the code. The stage five is testing. Testing is a procedure that can just tell that the absence of presence of the bugs or errors. We cannot correct the errors in this stage. Only we can know that there is error or not. So building software is not the end. Once the code is developed, testing is performed. It is a process to find out the bugs or errors. During the testing stage, developers will go over their software with a fine-tooth comb. Any bugs or defects that are needed to be tracked, fixed, and later retested. During this stage, unit testing, integration testing, system testing, and acceptance testing are done. Unit testing is testing which is done at very ground level, or we can say it is a testing that tests a very basic element. Integration testing is to test the combination of the modules, and the system testing is a testing that tests the software as a whole. So this is the stage 6 deployment. Once the software is certified, or we are done with the implementation part, and there are no bugs, there are no errors, then it is the right time to deploy it. We have to release formally in the appropriate market. The product may be first released in a limited segment. Limited segments means in limited crowd, and that it is tested in the real business environment. In this stage, user acceptance testing is done. User acceptance testing means the certain type of users they can test the product. If they are satisfied with this project or this software, only then we can release it in the market. Then based on the feedback, the product may be released as it is or with suggested enhancement in the targeting market segment. Means if customers are satisfied, then we can okay with the deployment of the software in the market. But if there are some suggestions from the customers, again we have to implement it, and only then after implementation all the feedbacks or suggestions, then we deploy the software in the targeting market. Now this is the stage 7, that is maintenance. Once when the client starts using the developed system, then the real issues comes up and the requirements to be resolved from the time to time. This procedure where the care is taken for the developed product is known as the maintenance. This maintenance is a process which starts from using the software in the real time on the side of the real customers. So these are the 7 stages that are involved in SDLC. After discussion, discussing the stages, now we are moving to the SDLC models. The first one is waterfall model. Then second one is prototyping model, spiral model, and iterative model. The first one is waterfall model. The picture is very clear as it is a name. It looks like a waterfall, and we can see there is no track that is going back to the previous stage. These are the 6 stages in waterfall model. The first one is requirement analysis. Second one is system testing. Third one is implementation, then testing, deployment, and maintenance. The picture that I have taken from the Google, it may be vary from site to site or the resources, but these are the major 7 steps. as we have discussed the SDLC complete process, and we have seen these all the steps as a requirement analysis to gather the requirement, system design to design the system architecture, and UI implementation means the coding part. The testing means they test the complete the coding portions, and the deployment is to deliver the software in the market, and maintenance means to maintain the software after deployment. So these are basic facts about the software model, waterfall model. The waterfall model is the very first process model to be introduced. It has a name waterfall model just because of the uh, diagrammatic presentation of the model. This model is a this model is a sequential model. Sequential means we have to complete a first phase before going to the next, and we cannot go back to the previous stage. The process occurs in order and do not overlap. It minimizes the planning overhead. It is difficult to define all the requirements in the beginning. It is not suitable for making changes, so it does not work well with the large projects. Real-time projects are rarely sequential because it is not fixed that we cannot go back to the previous step, and we are done with the one step, and now we have to implement the second step. Certain changes may be there. This is the prototype model. The picture is very clear with the idea behind the prototype. If we see these steps, the first one is requirement analysis, same as in the waterfall model. Feasibility study means is it feasible to do the things? Feasibility can be different types: economic feasibility, operational feasibility, and etc. Now the third step is prototyping. We have software design. So we after designing the software, we have to make the prototype. If, After completing the prototype, we have to have hand over to the customers, or we can say we have to evaluate through the customers. If customers are satisfied, then we can proceed with the coding, software testing, and maintenance. And if they are not satisfied, then we have to make changes. We have to work on customer review, and we have to update the prototype. Then we have to design the software, and we can go further after customer is satisfied. Otherwise we have to be in the loop only. So these are the basic facts in the for the prototype model. There was the issue that we cannot go back in the waterfall model. That was the issue, but we came with the solution, that is prototype model. By using prototype model, we can define the requirements. Why we are saying that we are defining the requirements as we go back to the this model? If we see after the third step, we are making prototyping, and we are continuously evaluating this prototype by the customers, and we are reviewing the customers points and updating this prototype. So this is how we are continuously refining the requirements, and it is better that we are defining the requirements so that we can deliver exact product, or efficient product, we can say, the right product. because working model is evaluated by the customers. This point can be neglected as we have discussed the third step. The prototype in this prototype model feedback to the developers. That is, again, we can go to the prototype model. If we see this this customer review, that is feedback to the developer, and developer can be easily modify the design, and they can work upon this part only. This model is flexible in the design. It can be reused by the developers for more complicated projects in the future. It ensures a large, greater level of the customer satisfaction and comfort. Uh, this is the this is the model that works on customer satisfaction and comfort only. If we satisfy the customer by the design or by the idea, then it is very easy to work on the rest of the project, and we get very less error, or we can say that we get very less dissatisfaction from the customers. It helps developers and users both understand the system better. There are few disadvantages about prototype model. This model is costly because we are working again and again in the same requirements. It has poor documentation because of continuously changing the customer's requirements. There may be too much variations in the requirement. Customers sometimes demand the actual product to be delivered soon after seeing an early prototype. The people think that we have seen the prototype, it means half of the product is completed, and the developers will take very less time to develop. But that is not true. The prototype model is not the half of the product. It is just a basic idea of the, I would say, uh, basic idea of the software, or it doesn't involve each and every function. It involves only basic requirements. There may be suboptimal solution because of the developers in hurry to build the prototype. Customer may not be satisfied or interested in the product after seeing the initial prototype. If customer is not satisfied with the prototype, they may lose the interest to give the chance to the developers, same developers, to the develop that project. They can choose other party as well. There is certainty in determining the number of iterations, and this is the spiral model. If we see this model, there are four quadrants. The first one is determining objectives, alternatives, and constraints. Then second step is evaluate alternative, identify risk, resolve risk. Third one is develop, verify next level of the project. And the fourth one is plan next phase. In the first stage or first quadrant, we determine the alternative and constraints. And if we see the second stage or the second quadrant, there is a risk analysis in every prototype, in every phase, which is a main strength of this model, or we can say which is the main functionality of this model. Then in third quadrant, designing, coding, unit testing, integration, acceptance testing, and implementation that are the part of the third quadrant. In the fourth quadrant, the development for the next plan, integration and test plan are involved. These are the basic facts for the spiral model. Uh, See, in previous models, we are not dealing with the uncertainty. So there may be serious issues, and we could face serious, I would say, the serious problems. So that was the problem. So project were failed because risks were neglected. If we see last two pictures, there was no risk analysis process. But in this stage, project were failed because risks were neglected or nobody was prepared for unseen hap happen. So this solution for that problem is a spiral model. It is a risk-driven approach. The radial dimension represents cost C. This radial dimension that represents the cost. And if we see their angular momentum that represent the progress. See, if we say we complete this complete one cycle, we can say we are done with the 10% of project. Again, then we are done with the second cycle. We can say we are done with the 20% or 30% of the project. So this is how this spiral model works. So there are few advantages and disadvantages of a spiral model. So high amount of risk analysis, hence avoidance of risk is enhanced. If we see this second quadrant, each and every step we are analyzing the risk. This was the first advantage. The second one is it is a good for a large and mission critical project. I mean, it is if we are if we are going to make a large project, then we definitely use this type of model. The third benefit or advantage of this this model, a strong approval and documentation control is there. Additional functionality can be added at a later date. And it can be a very costly model to use because we are dealing with the risk analysis in every phase. Risk analysis requires highly specific expertise. So we cannot give the risk analysis process to the layman or to the new learner. We need very highly qualified or expertise in risk analysis. Only that people can deal with the risk analysis. Project success is highly dependent on the risk analysis phase. Again, I'm saying the risk analysis is the main concern of this model. If we are not doing the risk analysis, then there is no point to develop this model. We can, work with the prototype model, iteration, or waterfall. It doesn't work well with the smaller projects. So we don't want to increase the cost of the small project, and so we don't use it as small projects this model. So the last one is iterative model. If we see the complete picture of this model, there are number of iterations are there. In each and every iteration, new functionality, new module, or we can say a new feature can be added to the model. These are the basic facts for the iterative model. Classical waterfall model is hard to use, so iterative model can be thought of as incorporating the necessary changes to the classical waterfall model to make it usable in practical software development projects. It provides feedback path from every phase to the preceding phase. This is the main difference between the waterfall and iterative model. It starts with the simple implementation of subset of the software requirement. Iteratively enhance the involving versions. At each iteration, design modifications are made and new functional capabilities are added. That is what I'm saying. Uh, I was saying in the first step. See, if we see this first iteration, then we add a new functionality in this module, and in second iteration we are adding new feature or new module, or we can say new functionality to the system. After completing the second iteration, again we are just adding the new functionality in the third iteration. In each iteration we are adding the new feature or module or function to the software. The advantages of iterative model is testing the debugging during a smaller iteration is very easy, because if we are just dealing with the one module, it is very easy to identify the error or debugging as if we compare as a whole software. A parallel development can plan. We can do parallel development. It is easily acceptable to ever-changing need of the project. Risks are identified and resolved during iteration. If we are done with the one iteration, then we are on second iteration. It is very easy to identify the risk and resolve at that time only. Limited time is spent on documentation and extra time on design. These are few advantages, and these are some disadvantages of iterative model. It is not suitable for smaller projects because uh, we can identify the risk debugging in a smaller project as a whole and at one time. So we are not using it in smaller projects. More resource may be required. Design can be changed again and again because of the imperfect requirements. Design requirement changes can be caused over budget. Project completion date not confirmed because the changing of requirements. So this is what we have discussed about the SDLC and the models. So if you have any question, you can post, and I will try to answer as soon as possible. So thank you very much.